So here we've got several charges in trying to be represented in 3D. What we're given is 4 positions, and I'm just going to use this notation, which is used in the question, just for ease, and I'll then rewrite it afterward in our x hat, y hat, and z hat directions. So we have 4 charges with charge Q1, Q2, Q3, and Q4. And it's wondering, or the question is asking, what is the proper ordering of the electric fields at points O, which is the origin, P1, which is 0, 2 along the z direction, and P2, which is 2 along the x direction. Now our electric field at some point, which I'm going to just call I, is 1 over 4 pi epsilon naught Q over R I squared R I hat, which is 1 over 4 pi epsilon naught Q over Ri squared times the vector in the direction of Ri over Ri. And so you can wrap these into Ri cubed there. So to get this, we're going to need all our vectorial directions. And just for consistency here, or just as a reminder, so if we're looking at the distance between a charge, say this is our charge point, and we want there's our vector P to some point, and this is then our I vector. Our I vector is our P minus our Q. So it's the point we're looking for minus the distance to the charge, or the vector to the charge. So now we're going to do the O point first. So then so this would be the E field for each charge, and to get the E field for all 4 of our charges, we would just sum it up. Okay, so now we're looking for RO1, and so then that's RO minus R1, which is 0, 0, 0, minus our point 1 was 1, minus 1, 1, 0, which is 1 minus 1, 0, which is 1 x hat minus 1 y hat. Our RO2, RO minus R2, minus 1, 1, 0, minus 1, 0, 1. Sorry. That's 1 minus 1, 0. which is minus 1, 1, 0, which is minus 1 x hat plus 1 y hat. Okay. RO3 is RO minus R3. 0, 0, 0 minus 1, 1, 0, which is minus 1, 0, which is minus 1 x hat, minus 1 y hat, and then RO4 is RO minus R4, 0, 0, 0, minus 1, 1, minus 1, minus 1, 0, which is equal to 1, 1, 0, which is 1 x hat plus 1 y hat. Okay, so now our E field total is, we can take out the 1 over 4 pi epsilon naught, Q1 over R1, 0, or I'm just going to call this R1 for now. So R1 cubed, R1 vector plus Q2 over R2 cubed, R2 vector. I'm going to call these, I don't know what I should do. I'm just going to call the point that we're looking for I, like this. There we go. And I'm just doing this generally first, just because I know that we're going to get an expression out that we can simplify a little bit. Because we're going to need to do this 4 times. Alright, and now we're given that each of the Q's is, so we're given that Q1 equals Q2 equals Q, and Q3 equals, and Q3 equals Q4 equals minus Q. So we can pull the charges out and say that this is Q over 4 pi epsilon naught Ri1 vector over Ri1 cubed plus Ri2 vector over Ri2 cubed plus, minus Ri3 vector over Ri3 cubed minus Ri4 vector over Ri4 cubed. Okay. So now we need each of our normals. So Ri1 came out to be 1 x hat, or RO1, sorry, came out to be 1 x hat minus 1 y hat. So this expression we'll be able to use the whole time, but we're going to do it specifically for the O point here. So RO1 magnitude is the square root of 1 squared plus 1 squared, which is square root of 2. RO2 vector was minus 1 x hat plus 1 y hat. So RO2 magnitude is square root of 1 squared plus 1 squared, which is square root of 2. And I think you can see a pattern here. So RO3 is minus 1 x hat minus 1 y hat. So RO3 magnitude is square root of 2. And RO4 is 1 x hat plus 1 y hat. So RO4 is the square root of 2. Okay, so then using our expression for our total E field, which was Q over 4 pi epsilon naught. So we can sub in our values here. So we had 1 x hat minus 1 y hat over root 2 plus minus 1 x hat plus 1 y hat over root 2 plus, or sorry, minus 1 x hat minus 1 y hat over root 2 minus 1 x hat plus 1 y hat over root 2. So then that was our 4, 3, 2, and 1. And we can see here now that this will cancel with this will cancel with this will cancel with this, and this will cancel with this. So our E0 is then going to be just 0. So our E at our origin is just 0. Okay. So now for point 1, we will have the same kind of E field expression, but now we need to solve for each of the other vectors. So our P1 1 is the difference between our point and our charge. So then this equals 1 minus 1, 2, which is 1 x hat minus 1 y hat plus 2 z hat. Right away we can see, or we can solve for our magnitude, which is square root of 1 squared plus 1 squared plus 2 squared, which equals square root of 6. Our P1, 2 is 0, 0, 2 minus 1, 0, which comes to minus 1, 1, 2, which is minus 1 x hat plus 1 y hat plus 2 z hat. Our magnitude, P1, 2, comes out to be, as you can see, it's going to be the same, so root 6. Our P1, I just realized those wouldn't be just root 2, those would actually be to the root 2 cubed, but it doesn't matter, they still cancel. Can't forget that. So RP1, 3 is 0, 0, 2 minus 1, 1, 0 minus 1, 2. So this is minus 1 x hat minus 1 y hat plus 2 z hat. We can see that our magnitude is root 6 again. And our P1, 4, 0, 0, 2 minus 1, 0, 1, 1, 2, which is 1 x hat plus 1 y hat plus 2 z hat. And again, our magnitude is root 6. Okay, so now our total E field for point P1 is our Q over 4 pi epsilon naught. Our R1 vector which is 1x hat minus 1y hat plus 2z hat over 6 to the 3 halves. So that's root 6 cubed. Plus our 2 vector, which is minus 1x hat plus 1y hat plus 2z hat over 6 to the 3 halves. I'm just going to make this a big square bracket and write down below just for space reasons here. Minus 1x hat minus 1y hat plus 2z hat over 6 to the 3 halves. And then this will be minus, did I? No. Anyway, okay. Minus a 1x hat plus 1y hat plus 2z hat over 6 to the 3 halves. Okay. So we can see again that these cancel. These will cancel with this will cancel with this. And we're going to end up with q over 4 pi epsilon naught. And so this is, and we can pull out the 6 to the 3 halves, in fact, as well. And we've got 2z hat plus 2z hat minus 2z hat minus 2z hat. And so I believe this comes out to be 0 again. Okay. So point 1 is 0 as well. And now at point 2, well, for point 2, we need all of our unit vectors. So then R1P2, or sorry, RP21, I should say, is RP2 minus R1, which is 2, 0, 0, minus 1, 1, 0, which comes out to be 3 minus 1, 0. So 3x hat minus 1y hat. And the magnitude of this is then the square root of 3 squared plus 1 squared. Which is the square root of 10. RP22 is RP2 minus R2, which is 2, 0, 0, minus a 1, minus 1, 0, which comes out to be 1, 1, 0. So that's 1x hat plus 1y hat. So then the magnitude of this is square root of 1 squared plus 1 squared, which is square root of 2. So now we've got different magnitudes. So we're not going to be able to do things quite as simply here. And so this is 2, 0, 0, minus 0.3 is the 1, 1, 0. So this is 1 minus 1, 0. So that's 1x hat minus 1y hat. So then the magnitude of this is square root of 1 squared plus 1 squared, which is square root of 2. And finally, for 4, two, 0, 0, minus 1, 0 is 3, 1, 0, which is 3x hat plus 1y hat. So the magnitude of this guy is root of 3 squared plus 1 squared, which is square root of 10. So now our E field at point 2 is our Q over 4 pi epsilon naught. Our 1 vector, so that is 3x hat minus 1y hat over our, not root 10, 10 to the 3 halves. Plus our 2 vector, so that would be 1 x hat plus 1 y hat over 2 to the 3 halves, plus our 3 vector, which was, minus our 3 vector. Our 3 vector was 1 x hat minus 1 y hat over 2 to the 3 halves. And I'm going to just put 4 down below minus 3x hat plus 1y hat over 10 to the 3 halves. Okay, so we can see here that we're going to have some cancellations but not complete. So our 3x hat here will cancel with our 3x hat here because of the minus sign, but then the y's are going to double. So Q over 4 pi epsilon naught, so minus 2y hat over 10 to the 3 halves. And then here our x hats are going to cancel and our y's are going to double up. So minus, plus 2y hat over 2 to the 3 halves. Okay. So now it's completely in the y hat direction. So we can pull that out. And we can pull the 2's out. So this is going to be, so this is just going to be 2 Q over 4 pi epsilon naught y hat onto 1 over 2 to the 3 halves minus 1 over 10 to the 3 halves. I would solve that out, but there's not really much point here, so we can see that it wants us to do rank in order of decreasing electric field strength. So our magnitude of our EP2 is just this 2Q over 4 pi epsilon naught, 1 over 2 to the 3 halves minus 1 over 10 to the 3 halves. But we can clearly see that that's bigger than 0. So it's non-zero. So then in order of decreasing, it would be P2 is greater than P1, which is equal to our origin. So that's the one we're looking for. And, right, there's no solution here. either. So that's our solution there. And this one's just incomplete. So I'll just do that.